In this demo, we'll work with GPT models. Okay, to get started, I've opened my Microsoft Edge browser, and I've navigated to chat.openai.com, which redirects me to chat.openai.com/auth/login. Now, from here, if I don't have an account, I can select Sign Up. That takes me to the Create Your Account page, where I can specify an email address. I can also log in from here if I already have an account, or I can use either Google, Microsoft account, or my Apple account to sign up. Okay, so I already have an account, and I'm signed in with my Chrome browser. So let's go over to the Chrome browser by selecting the Chrome browser icon on the taskbar. Okay, and on the first tab, I've signed into chat.openai.com. Now, there are a couple of GPT models listed. I'm not signed up to a paid account with this account, so I have access to GPT 3.5 only. But that's pretty significant. Now, at this point, it's important to maybe discuss a couple of options on how to interact with ChatGPT. So there are several techniques for crafting effective prompts. Common techniques include defining the output format, providing context or examples, and asking the AI to think in step-by-step or to debate the pros and cons of some subject. So in the Send a Message field, I'll type, "Debate the pros and cons of the fusion of generative AI and cybersecurity." To send the message, I can either press Enter or I can select the Send icon. So I'll just press Enter. Then now ChatGPT is generating the response based on my request. Okay, so that's how ChatGPT works in the chat web-based application. On my second tab, so let's go over to the second tab, I'm open to platform.openai.com. Now here, I'm also signed in with the same account, and I have access to the full slate of documentation here. So if I select the Documentation tab, I have all the documentation for the OpenAI platform. I also have an Examples tab where there are numerous examples to play with. I also have a Playground tab where I can experiment with the platform. Let's select the API Reference tab. So this is the full API reference. And this is the other way that I'm going to be working with the GPT models. I'm going to be writing some Python code later in this path. So I'll need to install the OpenAI bindings. And to do that, I'll use the Python pip package manager and use pip install OpenAI to install the OpenAI bindings. Now, I'll scroll down and under Authentication, I'll select the API Keys link. Okay, and that brings me over to the API Keys page. Now it shows that I have an API key, but if I want to create a new one, I just select Create a New Secret Key. I can give it a meaningful name. I'll just leave the default for my demo, and then select Create Secret Key. That provides me with the secret key. Now I can copy that and save it somewhere secure, and when I'm finished, I can select Done. Now from here, if you want to revoke a secret key, you just select the trash can icon beside the secret key that you want to remove, select Revoke Key, and the key is revoked and will no longer be usable. Okay, so now over in the left navigation menu, I'll select Usage. And this is the usage page describing my daily usage over the past month. Now if I scroll down, there's a free trial usage section which provides me with a summary of my free trial usage. Now with brand new accounts, you do get some free trial usage. Language models read and write text in chunks called tokens, and the use of the API is based on tokens. You do get some free tokens with a brand new account. Now with my account, my trial period is over. So if I want to use the OpenAI API, I need to set up a paid account by selecting Set up a paid account. Now from here, I select Start Payment Plan. I can specify my payment details, then my usage billing starts. Okay, so essentially in this path, I'm going to be either working with ChatGPT, the web-based application, or I'll be using the OpenAI API to work with the GPT models directly. With that, we've explored some ways that we can work with GPT models. In this demo, we'll perform a simple ethical hacking exercise by leveraging generative AI and the OpenAI API to analyze threat intelligence. All right, I'm on my Windows 11 research machine. Now I've got Visual Studio Code open with a Python script named threat-intelligence-summary open. This code is a Python script that interacts with the OpenAI API to generate text using the GPT 3.5 model. It defines a function called AnalyzeInfo that takes raw data as input and returns a response generated by the GPT 3.5 model. Okay, so let's explore the code. Starting on line 3, I import the OpenAI Python module. Now, as the comment on line 1 states, in order to do this, first you need to install the bindings with pip install OpenAI. So I'll press Control backtick to open a terminal below the code, and down in terminal, I would type pip install OpenAI, and that would install the OpenAI bindings. Now, I'm not going to do that because I've already done that. So let's go on with the code. Okay, so line 6, I specify my API key, and then on line 9, I define a variable named dark web posts, which contains a number of dark web posts that our security team was able to scrape from the dark web. Scrolling down, okay, on line 30, essentially I'm creating the raw data by joining each of those individual entries from the dark web posts. And then, starting on line 33, this is where we're really doing the heavy lifting. So on line 33, the AnalyzeInfo function is being defined. It takes a single parameter, data, which represents the raw data passed to it in the call to the function later in this Python script. Now, lines 34 through 38, we create the engineered prompt. We do this by concatenating several lines of text, including on 38, where the string is formatted to include the data passed in to the AnalyzeInfo function. Okay, now, starting on line 40. Line 40 is where the OpenAI API call is made using the OpenAI.completion.create method. This method creates a completion task which generates text based on the provided parameters. And what are those parameters? Line 41, the engine parameter specifies the engine to use for text generation. In this case, the engine named text-davinci-002 is being used. This engine is a variant of the GPT 3.5 model optimized for generating text. Line 42, the prompt parameter is where we provide the input text or prompt for the text generation. It's set to the value of the engineered prompt string variable. On line 43, the max tokens parameter determines the maximum length of the generated text. In this case, it's set to 250 tokens, which helps to limit the length of the response. On line 44, the end parameter specifies how many different completions to generate. Here it's set to 1, so only one response will be generated. On line 45, the stop parameter can be used to specify a list of tokens that, if generated, will signal the model to stop generating text. If set to none, like it is here, the model will continue generating text until it reaches the max tokens limit. On line 46, the temperature parameter controls the randomness of the generated text. A higher value, for example 0.8, makes the output more random, while a lower value, like 0.2, makes it more deterministic. Here it's set to 0.8, meaning the output will be relatively random. Now, on line 48, after making the API call and receiving a response, this line extracts the generated text from the response object. The response choices list contains the generated completions, and response.choices0.text gets the text of the first and only, in our case, choice. The extracted generated text is stripped of leading and trailing white spaces using the strip method, and then on line 49, it's returned as the output of the AnalyzeInfo function. Okay, and on line 51, this is where we make the call to the AnalyzeInfo function and pass raw data. And then on lines 53 and 54, we simply print the analysis. Okay, so down in terminal, let's run the code. And to do that, I'll type Python and the name threat-intelligence-summary.py. And I'll use the tab key to autocomplete and press enter. Okay, so interesting. It returns a summary of posts that we found on the dark web. It tells us that there's a security flaw in Broken Arrow software, that there's a zero-day exploit, that there's an APT versus critical infrastructure. So I'm going to up arrow to bring the command back And I'm going to run the same command and see if we get something different. Okay, and we get something a little bit different. This time it actually references a CVE number, which was referenced in the dark web posts. And if we keep up arrowing and run a threat intelligence summary, because we set the temperature to 0.8, we should get something a little bit different even. And we do. This time it's in the form of a paragraph. With that, we've performed a simple hacking exercise by using generative AI and the OpenAI API to summarize some threat intelligence. In this demo, we'll use generative AI technologies to identify potential attacks. All right, to get started, I'm on my Windows 11 research machine. I've opened my browser and navigated to github.com/frogger, and the O is a 0, /IAtelligence. IAtelligence is a Python script that extracts the import address table from a portable executable and uses OpenAI's GPT-3 model to provide details about each Windows API imported by the file. The script also searches for related MITRE attack techniques and explains how the API could potentially be used by attackers. It also displays the file hashes and provides an estimate of the cost of the GPT-3 requests. The authors note that IAtelligence is their proof of concept for using GPT-3 for malware analysis and for quickly assessing the behavior of a malware based on its import address table. We're going to clone this repo. So I'll select the code dropdown. I'll select the copy icon beside the repo URL. Now down on the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. Now in Visual Studio Code, I have a text file open, and this text file contains the information that we'll need in order to set up an OpenAI API key environment variable. But first, down in Terminal, let's clone the repo. So I'll type git clone, and I'll paste the GitHub repo URL in and press enter. Okay, so now the repo has been cloned onto my local machine. So over in Visual Studio Code Explorer, I'll expand the new IAtelligence directory that was created when we cloned the repo, and I'll double click to open IAtelligence.py script. One of the other things that we'll need to do is install the requirements. And the requirements are listed in the requirements.txt file. So all we'll need to do is go down in Terminal and type pip install -r requirements.txt. Now keep in mind that I'm in the /demo directory, and that requirements file is in a subdirectory IAtelligence. So let's go ahead and do that then. So I'll type pip install -r /IAtelligence /requirements.txt. I'm using tab to autocomplete, and I'll press enter. Now I'll clear the terminal. And now with the IAT script open in Visual Studio Code, you should always keep your environment variables private and never hard code sensitive information directly into your code. So what we'll do is we'll need to alter this script. First, we'll import the OS module. So in the script on line 14, at the end of the line, I'll place my cursor and press enter, and then I'll type import OS. Now we'll need to also modify line 20. I'll highlight the double quotes, and now I'll type os.environ, and in square brackets, and within double quotes, in all caps, OpenAI _API _key. And that should be good. So I'll press Control S to save the file. And so now let's go back over to the text file, OpenAI _API-key.txt. And essentially what we're going to do is we're going to set up an environment variable with my specific OpenAI API key. So I'll highlight line 6, Control C to copy. Down in Terminal, I'll right click to paste the command in and press enter. Now if I want to confirm that the environment variable was actually created, I'll highlight the getChildItem command on line 9, and I'll copy it with Control C. Now down in Terminal, I'll right click to paste the command and press enter. Okay, and the results show that indeed I have set up the environment variable OpenAI _API _key. So we should be good to go. First I'll clear. And now one more quick look at the Python script. Okay, scrolling down to line 74, this is where the script defines the request underscore OpenAI function, and it's expecting the IAT to be passed in. Now scrolling down on line 97, this is the prompt, and it's a formatted string that includes the DLL name and the import name. Then on line 98, this is the call to the OpenAI API using the OpenAI.completion.create method. Recall that this method creates a completion task which generates text based on the provided parameters. And speaking of the parameters, let's quickly review the parameters. So on line 99, it's using the text-DaVinci-003 engine. If you're wondering what the main difference is between 002 and 003, it's that 003 has been trained on a larger data set, so it should be able to generate more accurate results. 003 can also understand natural language instructions and produce more detailed responses. Okay, now max tokens is set to 2500. On line 101, top P stands for top probability and controls the diversity of the generated text. Frequency penalty on line 102 is used to influence the model's likelihood of generating less common words or phrases. Line 103, presence underscore penalty encourages or discourages the model from including specific tokens provided in the prompt in the generated output. Line 104, of course, is the prompt to send to the language model. And on line 105, we have the temperature. And since this one is set to 0.6, it's going to be relatively diverse and creative. Okay, so now let's run the script and we'll reference a portable executable that I have in my demo directory, which is supposed to be the Visual Studio Code setup binary. So now, down in terminal, I'll type python./iaintelligence/iaintelligence.py. I'm using the tab key to autocomplete, and I need to reference the portable executable .portable_executable.exe, and I'll press enter. Okay, so now the script runs. It gives us the file hashes and provides an estimated cost of the requests. And at this point, it looks like it's going to cost around 29 cents to do this analysis. So just imagine, as ethical hackers, we can go to our organization and demonstrate that, look, we can check this malicious, potentially malicious portable executable and determine whether it is actually a malicious file for 30 cents. All right, now this can take upwards of 4 or 5 minutes, and I'll fast forward through this so that we can see how the output appears. The script completes and the report is generated. It provides details about each Windows API imported by the file and explains how the API could potentially be used by attackers. All right then. Well, with that, we've used generative AI technologies to identify potential attacks.